Okay, so let's keep going here, and now we have the information flow in this slide here. So you can see I kind of corrected some of my errors there in the meanwhile. Let's keep it going. So we have a production control department here. So we're going to put here in the middle, production control. So I expect you guys to be doing this, right, as I am doing it. Okay, so draw one of your own uh, value stream map. So we have a production control process in the middle, and it receive a customer forecast, right? So this is the forecast, 90, 60, and 30 days. So that's what they expect to be the total amount of demand for that period of time. And then they issue a forecast to their supplier. So 6 weeks forecast here. And then they send a weekly email here with their orders, and they receive a daily firm orders. Okay, from their supplier, from their customer, sorry. And you can see that all of these, oh, supposed to be an arrow. All of these are like this, like a thunder kind of a thing. And this is not. That's on purpose because this is an automatic information that's be sent with the system or linked with EDI, electronic data interchange systems. And this is manually done. So whenever it's manually done, you do an arrow like this. If they're the system doing automatically, you do arrows like this. Okay. Then they generate weekly MRP system here. So they have the MRP to help them out, the material requirements planning that will look at the demand for this, let's say 2 weeks ahead of time or a month ahead of time. We'll look at the inventory in each point. We'll look at the lead time that things take to get there and to do all this calculations to find out, what are the orders, what is the forecast, and what are the orders, and what are the orders that each place needs to be doing. So the MRP system here generate the weekly schedule. And then this weekly schedule is sent to the production processes. And also, we have a daily shipping information that comes from this daily order, sending here to shipment so they know what to ship to the customer. Okay, so this is the information flow that we have in our process here, information coming to the fork, to the supplier, and then to each step of the process. So I think we didn't use information here about the supplier. We forgot to put there on the supplier. The steel coils are supplied by Michigan, delivered to ACME, arrived on Tuesday and Thursday. So we forgot to put that. When I say we forgot, I mean I forgot. So we have coils here, right, that are delivered. Oops. On Tuesday and Thursday. And put like this, Tuesday and Thursday. Okay. And here we have everything we need for current state in terms of information. The next thing we need to do is put that time stamps here to see how long each step takes, how much inventory I have, how much value added, and how much non-value added I have. So how do I build this rule? Whenever I have a process, I put it below. Whenever I have an inventory, I put above, right? So think about the process is the bigger one, so it just makes more sense to put it there. And then here, we're going to calculate basically two very important things. One, which is the one that's going to go below, is the total processing time. Total processing time. And here is the total lead time. So how do I calculate the total processing time? So it's only taking in consideration the value added steps. Okay, so let's think about here, right? So here we have a press is a value added step, the weld 2, assembly 1, and assembly 2. You have to take the time that takes from product from the beginning to the end of that process. So this is 1 second, the cycle time, and I can only put one at a time. So if I look the time it takes from here to here, it's going to be 1 second, right? The weld is also doing one at a time. So whenever it's doing one at a time, the cycle time is going to be the same as the processing time, okay? Because you're doing one. If you're doing two at a time, then it will take more time to go through the process. If you're taking, for example, a batch of 10 different items, oops, and it takes half an hour to go through the process, then there is a difference between the cycle time and the total processing time. Okay, 62 seconds. So this is how long it takes from the beginning to the end. This, the cycle time, is the pace of the process. So if you have a batch, you have to take that time that takes for the whole batch to be processed and divide it by the number of products that you have within the batch to calculate that cycle time. Or you just put the cycle time and then write it down that this is the batch of 100 items or something like that. So the total processing time, I'm just going to add this up. So 40 plus 62 plus 46 plus 39 plus 1 second. All the processing times, all the steps give us 188 seconds. Okay? Now we're going to calculate the total lead time. So total lead time, I'm going to have to calculate the inventories here between the process steps. So the first one, the problem already gave us, that's 5 days. But the other ones is telling you in number of parts, right? So have 4,600 and 2,400 of R. How do you transform this into time? So the way to do that is to use the Little's Law. And the Little's Law, you guys probably had that in core operations management classes. You have to understand how long something takes to go through a waiting line. You take the amount of people, in this case inventory, and you divide it by the daily demand. So that's because that's the rate of things going out of our system, right? So it doesn't matter if it's very fast here in the middle, the pace that things are going to get out of the system is based on the demand, right? So we're going to take let's say to calculate this inventory is going to be the 4,600 plus 2,400 divided by the daily demand, and the daily demand is going to be 18,400, which is the monthly demand, divided by 20, because we work 20 days in a month. That's 920 parts per day, right? So we're going to use the 920 here. And we're going to get to 7.6 days. And that's what we're going to put it here, 7.6 days, okay? So we have to do the same thing for all the others, right? So if we're going to put it here, so it's going to be 1,100 plus 600 divided by 920, and then it's going to be 1,600 plus 850 divided by 920, and finally 1,200 plus 640 divided by 920. And that is 1.7, 2.2, 2.6, okay, days. All days, right? And then we're gonna take this information and put it here. I'm gonna put D of days, 2.6 days and 2 days. Oops. Oh, there's one missing. So finished good is 2,700 plus 1,440 divided by 920. And that is 4.5 days. So here we have 4.5 days. Okay, so I have this information now. Now, what I need to do is to add all those days together to have the total lead time. So remember, the total lead time is all the non-value added, which is this one, plus the value added here. But it is only 188 seconds of value added, so not that much. Here is where I have most of the time. Okay, just make a correction. Here's 1.8. Okay, guys, this is 1.8 days. So 23.6 days total. So what does that tell us? Well, it tells us a lot, right? It tells us that to add value 188 seconds, I actually have material enough to produce 23.6 days. And 1 month, remember, is 20 days. So more than a month of inventory, more than a month, the time on average it takes a part to get from here to here. And I'm only adding value 188 seconds, right? So what the lean system will do is will reduce that time that it takes by reducing the inventory, making sure that you're producing more and better and only what is necessary with whatever is necessary. And you can see that here we have what we call a push production system. And that's the last thing we're gonna draw. What is a push production system? So there's two ways we're going to learn more about the pull production system, but the push will be whenever I'm producing things and it's not on the same pace of the customer needs. So regardless of what the customer process needs. So for example, if this weld, for example, has an uptime of 80%, if that breaks for some reason, Weld 1 will not stop producing because they're receiving information from schedule. So whenever you're receiving information from another source and you're not connecting the process, we're going to call it a push production system. So Weld is producing as much as they can and then pushing everything to the next step. Press is doing as much as they can, pushing everything for the next step. So don't care about Weld 1 is doing. I'm going to do as much as I can because I'm receiving the information from here, right? And that's the same thing for all these processes. And we're going to learn what does a pull system look like, okay? And this is your value stream map. So you can write the value stream map here. You can put the date here, the date. This is ACME, current state. I don't know what date are you guys watching this video. Put it there, and you want to put your name here on top, and just hang it in the fridge. See, this is the beautiful thing I did for my business process management class, and show to mommy and daddy. And let's go into how to transform this mess with 23.6 days and all this inventory into a linear process. What does the linear process looks like?